My dear students, this session we are going to see radiation between the plates using Kirchhoff's law. Now, let us solve an example problem. Two parallel plates of size 1 meter into 1 meter, spaced 0.5 meter apart, are located in a very large room, the walls of which are maintained at a temperature of 27 degrees Celsius. One plate is maintained at a temperature of 900 degrees Celsius and other at 400 degrees Celsius. Their emissivity are 0.2 and 0.5 respectively. If the plates exchange heat between themselves and surroundings, find the net heat transfer per each plate and to the room. Consider only the plate surfaces facing each other. Now we are going to solve. Given data is size of the plate, distance between the plate, room temperature, first plate temperature, second plate temperature, and two plates emissivity. First plate emissivity is 0.2, second plate emissivity is 0.5. We are going to solve. Let us consider this as an electrical circuit. It is called electrical analogy. Now we are going to solve like this as shown in figure. Node J1, node J2, node J1, node J2 and J3. We have three nodes. J1 and J2, we are considering it as a first plate and second plate. Now these two plates is going to give the heat to the room. So the current flows from J1 and J2 towards J3. It is shown in figure. We are going to find the net heat transfer to each plate, net heat transfer to the room. Now area A1 is equal to 1 into 1, so 1 square meter. A1 is equal to A2 is equal to 1 square meter. Since the room is large, we are considering A3 is infinity. Since the room is large, A3 is equal to infinity. From electrical network diagram, 1 minus epsilon 2 by A2 epsilon 2. From electrical network diagram, 1 minus epsilon 1 by A1 epsilon 2 is equal to 4. Similarly, for 1 minus epsilon 2 by A2 epsilon 2 is equal to 1, and 1 minus epsilon 3 by A3 epsilon 3 is equal to 0. Since A3 is infinity, we are going to substitute this in electrical network diagram. Then the drawing will be like this. To find the shape factor F1 to 2 in your data book, from graph x-axis x equal to L by D is equal to 1 by 0.5. L and D is given. L and D is given in our given data. L and D is given in our given data. We are going to find the curve in our data book. First find L by D, it is equal to x. Then find B by D curve, it is equal to 2. For this curve and x value, find the corresponding value, I mean shape factor. In your data book, it is 0.41525. So your shape factor is F12 is equal to 0.41525. We know that F11 plus F12 plus F13 is equal to 1. It is summation of all radiations is equal to 1. It is the logic, but F1 to 1 is equal to 0 because it is a flat plate. So you can find F13 is equal to 1 minus F12. We know the value of F12 already. So you can find F13 also. F13 is equal to 0.5847. The similar procedure is maintained for equation here. F21 plus F22 plus F23 is equal to 1. F22 is equal to 0. Okay, we can find F23, F21 also. Now, substituting these values, you can get the value of 1 by A1 F13, 1 by A2 F23, 1 by A1 F12 as shown here. From Stephens-Boltzmann law, EB is equal to sigma T power 4. For emissivity, EB1 is equal to sigma T1 power 4. We are substituting the values. You can get E suffix B1 is equal to 107.37 into 10 power 3 watt per meter square. Similarly EB2, similarly EB3. Right. These radiosities J1 and J2. Now we are going to find the values of J1 and J2. At node J1, consider the node J1. The current coming towards J1 is shown here. It is EB1 minus J1 by 4 plus J2 minus J1 by 1 plus EB3 minus J1 by 1 is equal to 0. From electrical network diagram, we obtained this equation number 1. Similarly, at node J2, it is summation of all currents coming towards J2. You can obtain equation number 2. Solving the equation 1 and 2, you can get J1 and J2. Now, substitute the values of J1 and J2 in heat transfer equation. You can get Q1 and Q2 as shown here. Q2 is equal to EB2 minus J2 by 1 minus epsilon 2 by A2 epsilon 2. We found Q1 and Q2 separately. Adding the heat Q1 and Q2, you can get the total heat loss by plates. It is 21.06 into 10 power 3 watts. The total heat received or absorbed by the room is Q is equal to J1 minus J3 by 1 by A1 F13 plus J2 minus J3 by 1 by A2 F23. Now we are going to determine Q from this equation. It is 20.752 into 10 power 3 watts. Heat lost by the plates is equal to heat received by the room approximately. This is the result for this problem. It is Q1 and Q2 and the net heat transfer. Thank you for watching.